This conference will now be recorded.
Not clear? Somebody saying sound is not clear. Sound is not clear?
Sir, for me, it is okay.
Okay, Preeti, I guess you have some internet issue on your end.
Audible, sir.
Okay, great. So I would request all of you to please keep yourself on muted. Otherwise, it will create problems.
Audible, sir, or audible.
Okay, great. So let me start the session now. So first of all, I welcome you all to the webinar. And this webinar is about data science and machine learning, AI and deep learning. So my name is Nandesh, and I'm a data science consultant and a trainer working with Brillica services from past 2 years. And I will be taking this webinar. So let's discuss the agenda. What are the things we are going to cover in this webinar? So first of all, we'll look at the introduction to data science, and then we'll look into the tools and techniques that are used by the data scientists. And then we'll see the data science with Python, and then we'll see the introduction with machine learning and deep learning. And then we'll see the different techniques that are there for the data mining, data classification, and data analysis. And then we'll see the use cases, different use cases in various industrial aspects. And what is the market for data scientists in India, salary packages, requirements, scope, and etc. And at the end of the session, we will have a Q&A round. Okay. So first of all, before talking about what exactly is data science, we need to know why do we need data science? Why exactly is that? What is the need for data science? Let's try to understand that. So traditionally, the data that we had was almost structured and small in size, which could be analyzed using the simple tools like Excel or maybe some sort of doc file, some sort of simple BI tools that we have if we have a structured data. Unlike the data, that traditional system, which was mostly structured, today most of the data is unstructured or semi-structured. So by what do I mean by unstructured kind of data? Unstructured kind of data would be like that data generated from the IoT devices, from electronic devices, transactional sort of data. That will be kind of unstructured data that do not have a particular structure that it follows and do not have a schema that it follows. So let's look at the growth of the data, how the unstructured data and the structured data is growing till 2020 by this graph. So as you can see from 1970s, the growth of the unstructured and the structured data, the growth of the unstructured data has been exponential after 2000, as you can see, and it has been continuously growing. And it's almost 80% now. Now the total data that is being generated, almost 80% of the data is unstructured, and only 20% out of that particular data is basically structured data. So to deal with structured data, we cannot use simple BI tools like Excel or any sort of tools, the basic tool that you have available for the analysis. So what are basically the different sources? Again, you might have in your mind this question, that what are the different sources again the data is being generated. So as I've said before, it could be financial logs, it could be the text file, the multimedia form, the sensor, and the instrument that you have, different electronic and electrical instrument that you have which generated data, IoT devices, that sort of thing. So they generate basically unstructured data. And to handle that particular data, there has to be some sort of techniques, there has to be some procedure that we have to follow, that we would be able to tackle that, but in that kind of data we would be able to work on that kind of data. And again, it's one of the examples in which machine learning is used. I'll come to this example again later on in the section, how machine learning is being used. Now let's come to what exactly is data science. So data science, if I keep it very short and very simple for you, so data science is a blend of various tools, algorithm, machine learning principle with the goal to discover hidden patterns from the data. And that is what we are trying to do. We are trying to discover what the story of that particular data, what is the story of that data, what are the patterns that are hidden inside my data. Basically, that is what we are trying to figure out with the help of machine learning, with the help of different algorithms that are available to us, and we are trying to solve a particular problem. And then comes what are the key things are required. As you can see through this diagram, that the basic thing for somebody to be a data scientist, he needs to have a knowledge of mathematics, he needs to have a knowledge on computer science, and he also needs to have a knowledge of domain. Basically domain, whatever domain he might be working on, maybe it could be a domain related to healthcare, maybe it could be related to pharma, or it could be any domain. So he need to be aware about that particular domain which he wants to work on. Then
Excuse me,
somebody
sir.
Yes.
Yeah, sir. One question means I want to say कि you will provide that PPT to us, or otherwise we can make notes.
Yeah, you can make notes. I'll try to share the PPT as well,
Uh,
but if you can make notes as well if you want.
uh, okay. So, sir, if you provide a PPT, then we will not make notes now. That's why I'm asking just.
Okay, no problem, no problem. I will share the PPT.
Okay. 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 Okay.
Okay.
Thank you, sir.
No.
Thank you, sir.
So now somebody, I get this question a lot from the beginners, that what is the difference between an analyst and data scientist? So that is why I have put this at the front of the slide, so that it should be clear to what exactly the analysts do and what exactly the data scientists do. So basically the analyst deals with basically the business administration and the exploratory data analysis. What exactly is exploratory data analysis? The kind of historical data. If I give you some historical data of a company and try to ask you what are the hidden insight that you are able to find, are you able to find any pattern data? So if you give me some sort of patterns and you tell me that these are the pattern that I can see in this particular data, and that's all. And if I want to explore more things, and if I ask you more questions on that, you might not be able to answer those questions, that how to solve this particular business problem if I ask you this, and you might not be able to answer that particular question. So that will be the analyst basically. So the analyst deal with the exploratory data analysis. He try to analyze the data, whatever data is being given to him. He try to find out what are the different with the help of different type of visualization. He try to visualize the data and then try to find out what are the patterns that his data is following, what is the trend that he is able to find out in this particular data set. And then comes the data scientist. What exactly the data scientist do? He also does the same thing. He does the exploratory data analysis, because he also needs to understand what is the story of that particular data, how that data is being generated, what are the patterns this data is following. And then the most important thing that he builds the machine learning algorithm for predicting the future. That looking at the historical data, if we find out something and he wants to predict for the future as well, maybe we can consider a very simple example. Maybe we can think of machine learning is being used like in self-driving cars, like Google is testing self-driving cars. So Google, first of all, what exactly Google is going to do? Google is going to collect the data, how the data for the how the driving happens, basically how a car is drove from one point A to point B, what are the had hurdles that car face basically when is driving from one point to other point. Then it will analyze the data, and then looking at that particular data, what are the different decisions the car took. Looking at the red light, it got stopped. Looking at maybe somebody is passing, it got stopped. So machine learning algorithm will learn all these things and then try to predict for the future, that it has to follow the same step. And then comes the part of data engineering, that how the data needs to be fed into the system that it can make the prediction in future. And these are some of the differences that are there in the analyst and data scientist. Then comes what are the different tools that are available for the data science. So first of all, we need to work with the data sources that are there. Are different kind of data sources, there are different kind of databases that we have to deal with. Depends on the kind of problem we are trying to solve. It could be SQL databases, it could be no SQL databases, all sort of thing. Then comes basically again the transform. Basically, first of all, we connect the data, then we want to change how the data is looking to me. Then we will connect that to my programming infrastructure, whatever structure I'm working. It could be different infrastructure for big data infrastructure. If I have trillions of records, then I'll be working with maybe Spark or Hadoop, that sort of structure I'll be working on. And if I'm trying to solve a small problem, then I would be working on with maybe Pandas or a different kind of libraries. And then comes the part of model building. So the model building happen with the help of scikit-learn, and this is the library in which there are different models that are already available to me. I will be using this library, and for the data visualization, different kind of libraries again I'm using this, as you can see, matplotlib, cbond, day3, d3js, all different kind of libraries that are available there. And then there are some other tools as well, like Kafka and all different sort of tools. If I have large amount of data, like the amount of data Google is generating, the amount of data Netflix is generating, they would be working on this sort of tools basically. These tools help me.
So can you tell about?
If anybody have question, we will deal with the question in the last section. You can note down your question on a piece of paper, and we will talk about this in the end of the session. Please, it's a request from my end. Then comes the part of predictive analytics basically. So what exactly we are trying to do with the data? If I have a data, then looking at the data, what I'm trying to do, basically I am trying to solve a business problem. And how I'll be able to solve a business problem? By predicting the future basically, by telling them, my business owner or the client that I'm working with, what exactly is going to be the demand of this particular product that you are going to create. Is this product is going to succeed in the market, or what is the requirement? Trying to understand maybe the requirement of that particular product. And there is something called as, when if somebody is from out of you is an entrepreneur, you might have heard of this term, which is called, you have a product that you might be thinking of that you want to take to the market, and then you're not really sure of that whether this product, what exactly you want to find out, what exactly the customer will expect from this particular product. And then you try to gap up the bridge basically. You try to reduce the distance between your product and what exactly the customer is looking for, and we call that product market fit basically. So that is what we are trying to figure out maybe, and that will be done with the help of, again, predictive analytics, trying to understand the customer behavior, what all things it requires at this point of time, and then making a product in such a way that our customer can use, the customer can relate to that particular product. So there are different steps that are involved for predictive analytics. Basically, first of all, we define a business problem or define a project that we want to work on, and then what and all data that is required to solve that particular business problem. We try to collect the data. We try to go to different resources that are available to me and try to collect the data, and then we do the data analysis basically, and finding out what are the structure this data is following, all sort of patterns in this data is following. We try to find that out, and then comes the part of data modeling basically. We try to develop some sort of algorithm which will be able to make the predictions. If given some input, it is able to give me some sort of output which will be sort of predictions basically, whether this product will work, whether this product will work not work, what kind of demand this product have in the future or not. That sort of product can be built. Then comes the evaluation part is very important. If I have built the model and I'm not really sure what are the errors this model is giving me, so that is very important for me as well, that I should be aware about the evaluation part as well, that if my model is making some mistakes, then I need to go back again. Maybe I need to redefine my problem statement, or define the project again. Maybe I need to collect some more data. Maybe I need to do a data analysis in different way, and then maybe I need to change my model as well. And then I'll come back. If I find the evaluation satisfactory, then I'll move on with the deployment part, wherein I will deploy the model onto some server that people can use later on. Then comes the part of prescriptive analysis. This is something sort of a new field which there is a lot of research going on in the prescriptive analytics field. So if you want a model which has the intelligence of taking its own decision and the ability to modify it with the dynamic parameter, you will certainly need a prescriptive analytics basically. So prescriptive analytics example could be something like, you went to a doctor and the doctor asked you for your symptoms, how you're feeling. Maybe you went to the doctor with a symptoms might be like you have a high fever, and you're feeling cold also, and there is a lot of tiredness in your body. So based on these symptoms, the doctor does his own analysis, and based on his own analysis, based on his own experience, the doctor give you the recommendation of these sort of medicines that you have to take, and there could be a possibility of this sort of disease. He might give you this possibilities as well. That's what the doctor do. And maybe we want to build some sort of application or some sort of website which do the same thing. Ask for the symptoms from the customer, or from the client, and then give him some sort of prescription that these are the medicines that you have to take in, and these are the measures that you need to be aware of, that you need to take in care of, and these are the possibilities that you might have develop this sort of disease. So you can think of these examples are there relatively new field. As I said before, it's all about providing advice basically. In other terms, it not only predict but suggest a range of prescribed actions, associated outcomes basically. So what could be the possibility? It would not give him accurate answer, but it will give him that this could be possibility that you might have this sort of A type of disease, B type of disease, you should be taking care of yourself, or you should get yourself tested for this sort of disease. So the best example is basically self-driving car, Google self-driving car, and based on the basically the condition that the car is in, maybe it's in a very on a highway where there is a maybe a huge amount of traffic basically. So what sort of decision this car needs to take, then it will decide. Maybe the car is running at a very high speed and somebody comes in front of the car, how the car should stop, that is also very important. How the car should stop, how the brake needs to be applied. It cannot apply the brake immediately, or maybe it has to apply the brake immediately, and then based on that it will take the decision. It will not apply the brake in the same manner if a car is moving with 120 speed and there is a basically it sees a red signal or the red light, it will stop in a different way. But if it sees a person passing by the car and the car is going with a speed of 120, it will stop the car in a different way basically. So it's sort of intelligence that we are trying to give to a machine, that it can think in a way that the human brain works basically. Then comes the part of machine learning. So machine learning is the method of data analysis that automates the analytical model building. Now every time when we are getting data, we are building the model every time. So machine learning solves this problem for us, that we are not going to build a model every time whenever the new data comes in. I'm not going to analyze every time whenever new data, whenever new records comes into my system basically. So I'll build some sort of machine learning model which will automate this particular task for me, which will be doing this model building automatically in the backend. Whenever it receives the data, looking at the data that it has received, it will be building the model side by side and then making the prediction. So it is a branch of artificial intelligence based on the idea that system can learn from the data and identify the patterns. So generally, what exactly we do in case of programming, or in our life as well, what exactly we do, we define some sort of condition. When we go to markets, or when we are on the road, we have different if and else statement in our mind. Maybe I'm on the signal, so I will see if there is a red light, I need to stop. If there is a green light, I need to run away. If there is a yellow light, then I need to start. I need to be ready for the step that I need to take. Maybe I want to start up my car, and then I should be moving. So this sort of decision making ability we are trying to give to a machine, that it should be able to make the decision with minimal or no human intervention. That is what AI and that is what machine learning is trying to do. That we are trying to make the machine learn what we are doing basically in our life. Usually we have been doing from a couple of years. That is what we want a machine to learn, the same thing and perform the same task for us with more efficiency also. Then there are different kind of analytics that you will find. There is a descriptive analytics basically. So descriptive analytics deal with what happened basically. So if you give it a data to me and ask what happened to the data, what exactly you find in this data, why there is a downtrend in this data, why the sale is going down. So I might give you some answer. The demand is also going down. So that can be done with the help of descriptive analytics. So basically it does not make any prediction. It's simply looking at the information, just give you the answer basically. Then diagnostic analytics, basically why did it happen? Then again, we want to find out that why did it happen? The next answer that I give you already, that might be what was the reason for the sales going down. The reason for the sales going down might be, again, the demand is also going down. Maybe the product that we are trying to build is not of that basically quality. The quality has reduced because the raw material that we were receiving, it's not again of that grade. Maybe we were dealing with the grade B first of all, now we have a grade A product which is of a lower grade, let's say, for this in this case. So that is a part of diagnostic analytics. And then what happens basically, what will happen, that is we are trying to predict the future. that what will happen in the future. So looking at this data, looking at the demand supply chart, and looking at my raw material procurement, all of that data, if I gave you and then I ask you what is going to be the future, what will be the demand in future, what is going to be the demand of this particular product, is it going to sell more, is it going to sell less, all sort of things. So I'm not audible to everyone.
Sir, it's audible.
Audible, sir.
Audible,
Somebody
sir.
saying, somebody saying not
Audible,
audible.
sir.
Ajay Singh Rathod is saying that I'm not audible. Yash is also saying that not audible. Yes, recording is there, don't worry about it. You will get the recording for sure. So if anybody is having any question, please note them down and we will have the Q&A session at the end. Okay. So the difficulty again, then there comes the part of prescriptive analytics, that how can we make it happen? And this is very, very important for the business, because if you will tell me that this is the problem and this is why it is happening, if you tell me, and maybe you'll tell me that this will happen in future, but how we would make that happen, right? This is very, very important for the business to know. This is very important for us to know as well. And that is a part of prescriptive analytics, that what are the measures that I have to take for making that happen. If I want to be in that position, what exactly the measures, what are the steps that I need to take, and the amount of difficulty and the amount of value it increases with the different kind of analytics that you have. Of course, it is going to be much more difficult than the descriptive analytics. That's for sure. That because you are going to give, you are going to look at more data resources now, that how people have made this possible, how different people have made this possible, that this problem that I'm trying to solve, how other people have approached this particular problem. You might have to look at different resources and then try to figure out what exactly needs to be done to solve that particular problem or to achieve that particular goal that I'm trying to achieve. And then comes the part of machine learning. You might have this question, how exactly machine learning is used in different fields. So machine learning is used in every aspect of our life that we will see, and if it has not been used, it will be used in future. But how machine learning is used for the pattern discovery, because I've been saying this word a lot, finding the pattern in the data, looking for the pattern in the data. So how it has been used, so let's see. So if you don't have a parameter based on which you can make prediction, maybe if you don't have a features could be something like maybe you're trying to predict the price of a house. So for predicting the price of a house, if a house have some sort of price, so there will be some parameters associated with the price of a house. Maybe it could be the area of a house, maybe it could be the number of rooms that house has, maybe it could be like the average income of the people who are living in that particular region where that house is located. So I have these features and I can find out the correlation, that how these features are affecting the final price of my house. But if I don't have a feature, I really don't have that, what is affecting the final outcome. In that case, what exactly I'll be doing? In case of maybe when I'm trying to figure out the pattern, but I don't really know what are the features, what are the feature based on which I should be predicting the the patterns, then you need to find the hidden patterns in the data set. We'll be able to make the meaningful prediction, and this is nothing but unsupervised learning. So this is the part of unsupervised learning. I will talk about this again, what exactly is unsupervised learning, but for now you can say unsupervised learning is a kind of learning in which I don't really have the features, and still I want to make I want to recognize the patterns in that particular kind of data. So the mod, you don't have any predefined labels of grouping. Basically in that particular case, we will be going for the technique which is called as unsupervised learning. Again, it is a part of machine learning, and the most common algorithm used is basically called clustering, basically clustering data into different clusters. So if I show you the example of unsupervised learning, so this could be some sort of example for the unsupervised learning. As you gather the data of the existing, basically then you clean the data, then you look for patterns and similarity, and then segment the data according to the finding, and then analyze the segment and implement the insight to the business. So this could be the Google Lens example, which Google is able to recognize what exactly is written in here. It is able to find that out. Now, how Python is being used for data science. So before starting that, give me 2 minutes. I'll just write, just let me connect my laptop with the charger, and then we'll start. Okay, so Python for data science. So Python find a wide range of application for data analysis and data science, and it is a language of choice for large portion of the data science community because of the various tools which make it easy to work with the huge data set and gain the significant insights. The libraries such as Numpy, Pandas are extensively used in the collection, processing, and cleansing of the data set. And another aspect that make Python a great tool for data scientists is the robust visualization that come with the matplotlib and seaborn. So these are some of the most used library that are there for the data science. Basically Numpy, again Numpy basically is used for doing some numerical calculation. You want to do some array multiplication, you want to create a diagonal matrix, that is all possible. You want to create a matrix with 1 1 1, you want to create a matrix with 0 0, all zeros, that is also possible. Now Pandas is a library basically with which I am able to read my CSV file or Excel file or any JSON file or a data from a web that I can read. If it has a tabular data, I am able to read that particular data from the web or from the Excel. So it's, you can think of it as an Excel, but it's much powerful than Excel, because if I give Excel maybe 1 million record, Excel might crash, but Pandas will not. Panda will be able to handle that sort of capability. It has that sort of capability that it can handle. Then for the visualization, you want to draw some sort of graphs, maybe a bar chart or a pie chart or a scatter plot, histogram. That sort of things are possible with the help of matplotlib. Then you want to visualize the normal distribution. You want to create a data from the normal distribution, for the uniform distribution, from the standard normal distribution, which will have certain probabilities. You want to pick out the random variable. So all concept related to statistics, that is possible with the help of SciPy library. Then if you want to apply the machine learning algorithm, because nobody is going to code the machine learning algorithm, maybe a linear regression, random forest, logistic regression, all these different algorithms that are there. So they have been already coded for us in the scikit-learn library. They have been already coded for us. We simply have to learn that how exactly we can use those algorithms into a problem, what kind of data this model accept, because there has to be some procedure, there has to be some requirement that it would expect you to fed in your data basically into this particular that it can make the prediction. So we will understand that, and we'll learn how to basically use the scikit-learn library to solve a business problem, and we'll be able to do that. Then somebody have this question, and I get this a lot again, that why exactly Python, why not any other language? So these are some of the reasons why Python is being used so much, why people are using Python a lot nowadays. These are some of the reasons, because one of the most important reason for a beginner who is coming from non-programming background, it's very easy. It's very easy to read and very easy to understand. It has a syntax like English language, and you'll be able to easily relate with this language, not like any other language like Java or C++. It's basically expressive, as I said before. You'll be able to understand, and if you write some code and if you show it to somebody who might not be a computer programmer, he will be still able to read that particular code. Then open source, again it's open source, it has lots of libraries available that you can work with. Again, it's basically high level language, it's portable, object oriented part is there, all sort of thing, extensible, embeddable, interpretable, GUIs can be made. GUIs, like this is a sort of GUI. If you open an Excel, that is a GUI. Those GUIs can be made. A calculator, it's a GUI. So GUI is nothing but a graphical user interface. So that can be built with the help of Python. And it has a large basically libraries. Almost all the libraries that are there for data science, for NLP, machine learning, data science, all these libraries are present in Python basically. So now comes the part of machine learning, which I've been talking a lot in the previous slides. So let's try to understand now what exactly is machine learning. What are different parts of machine learning? Now, machine learning is what and why it matters basically. This is very, very important. So machine learning is a method of data analysis, as I said before, that automates the analytical model building. I just kept it very, very simple so that you can relate with this. Of course, there is much more complexity than that, but yeah, I just kept it very, very simple so that you will be able to relate with this. So it is a branch of artificial intelligence based on the idea that system can learn from the data and identify the patterns and make the decisions with minimal human intervention, just like we do. If I show you some picture, or if I may tell you some sort of business plan that we want to do this sort of business, so looking at my after hearing my conversation, you might understand that what this person is talking about, is it going to make sense to you? Is this business is going to be profitable or not? Nobody is going to come and teach you this thing, that how you should respond to the situation, but you will have your own intelligence which will respond automatically, that you will say, okay, I'll get back to you, I need some time, maybe I need to think about it, and then I'll get back to you. So this sort of intelligence we are trying to give to the computer, that it can behave in a way that the way we take decisions in our life. Then how is it different from the general programming? That's what we do in case of general programming as well. I define some rules. So it is different in a way. First of all, you have to give the data. Looking at the data, you define the rules, and then after that you get the output. Let's say for the simple example, if I give you 10 numbers, basically if I want to identify that out of those 10 numbers, how many numbers are even, how many numbers are odd, how many numbers are prime, maybe. Let's say that, okay, let's take two of them, that I want to find how many numbers are even, how many numbers are odd. So I will have to write the rules, that how to look for the number if that number is odd or if that number is an even number. And then I will give the data which are my different number, and then I will have the output. It will tell me if this number is a odd, if this number is even. That sort of output I will be able to get. But this is good. General programming is absolutely good when you are solving a simple problem. That is all possible with that. But when you want to solve a problem which is very complex, maybe some sort of, we want to analyze the transactional data, or maybe we want to analyze the data for the logistic company, that sort of data we want to analyze. Maybe we want to forecast the sales, that how the sales are going to look like in the next quarter. So how you are going to define the condition for that? What should be the conditions for that? We are not really sure of that the conditions are going to be. Maybe we will be able to write the condition, but what if we miss on something? Because we are humans and we make mistakes. So what if I miss on something? So then that will be problem. Then again I have to go back and write the rules again in general programming. But what happens in machine learning model, I give the data and I give the output upfront to the machine learning model, that this is my data and this is the output. Maybe the data could be about sales, and sales will be dependent on different variables. So sale could be dependent on different variables. Let's say what is the season, maybe what is the product that I'm trying to sell, what is the demand for that particular product in the market, and then I will tell how this many sales I have made. Now I will feed this data to my machine learning model, and I will ask it to define the rules, give me the rules, that how exactly the sale is related to my data. And then the machine learning model, it will give me some sort of rules with which I am able to identify that this is the relation the sales and other parameters are following basically. So that is when machine learning comes into picture. And for example, let's say I give my, this is called as labeled data, in which I'm telling this is Tom, this is Jerry, this is Tom, this is Jerry, this is Tom, this is Jerry. and this is a known output. So I was saying this again and again, that in the initial again, that I will give my data with the output, with the label. So what exactly the label? This is label. I am telling that this is Tom, this is Tom, this is a picture of Tom, this is Tom, this is Jerry. So I'm this is basically a picture, and I'm telling whose picture is it. So it's a picture of Tom. I'm telling this is a label, this is the output that you can think of. And I'm not telling what are the rules that Tom and Jerry are different from each other. There has to be some rules. Maybe the rules could be like, if I'm solving this problem with the help of general programming, I will write how many conditions I will write. There are going to be endless conditions that I might have to write, and then even I'm not sure whether those conditions are going to be true or not. Maybe if some Toms come with a very ugly face, maybe I'm not really able to identify that. So I will ask this machine learning model to identify this. I will give this data to my machine learning model, clean the data, do some sort of EDA on it, like exploratory data analysis. Then I will give it to the machine learning algorithm, and the algorithm will do some evaluation that how well it's performing, how bad it is doing, because it is going to make the prediction and they might be wrong. It will compare with the original output. It might, if I give him maybe this picture of Tom, it might say that it's Jerry. Okay, it will say no, it's not Jerry in the model evaluation phase. Okay, it will say, okay, I need to go back again, I need to do the next prediction. Then again it might make some other prediction, and then there will be error. It will calculate that error, try to fix that error, and once it comes with a better accuracy, then I will have a model. Now in future, if I give this some data, then I will be able to, it will, what exactly it will do, it will divide in two classes. So basically it will have one class for Jerry, one class for Tom. So next time if I'm going to fed any picture of Tom, it will put the Tom in this particular class, and if I fed a picture of Jerry, it will put him in this particular class. So this is a sort of classification problem in which I have two classes. And maybe I could have different type of problem in which could be the pricing of a house. That could, again, I will give it some features like I said before, like the house area, the number of rooms that the house has, the number of bedrooms the house has, how far that house is from the main market, what is the average income of people living in that particular area, these sort of features. And also I will give the price of the house, and I will fed this to my model, do the data cleaning, EDA part, and then fed it to the algorithm, and then model evaluation check. It will make the prediction looking at some feature, maybe 4 or 5 feature. It will predict the price of a house could be $100,000, and it will go and check now that is it really $100,000 looking at these features, these particular XYZ feature. Okay, it will say no, it's not, you are making an error. It will go back again, it will fix that, and then it will come up with another prediction, and this process continues. This is an iterative process. This continues unless it reaches to the point where there is a minimum error, and that is what we're trying to achieve. We want to make a minimum error as possible, and we want to build a model with better and better accuracy. So then I will have a model, and in future if I fed some features to my data, maybe I tell my model that if this is the carpet area, and if this is the average income of that particular area of people that are living in that area, these are the number of rooms, and this is the distance of my house from the main market, from the supermarket, then what could be the price? And this will give you a continuous value, a price value. Maybe it will say it could be $150,000, maybe it would say it would be like $140,000. So that sort of thing can be possible with the help of machine learning. Now you might say, what are the use cases of machine learning? How machine learning is being used? So these are the different examples that are there for the machine learning. One of them is basically Google self-driving car, as I said before. Then the web search result. Google is trying to be the company, the AI first company. They are keeping AI in their preference list in the first position. They want to do things with the help of AI a lot. They are working on the web searches as well. That before that, how SEO was working, that was different. If I say maybe 3 years back, 4 years back, how the search results, how they were ranked, there was a different techniques. But now every day Google is coming with a different algorithm that is going to rank a website based on different parameters. And it is also looking at how people are responding to that particular website. If somebody go to that particular website, how they are responding, how they are reacting to that particular website. Are they staying on that website, or are they immediately leaving out of that website? So again, in case of fraud detection, maybe there is a transaction, a credit card transaction is there. So we want to build a model. If we are working for a banking client, we want to build a model. If that transaction is a fraud transaction or a genuine transaction, then the credit scoring, basically the credit rating, how to check the credit rating, basically there has to be some algorithm which will do this. And then in pattern recognition as well, social listening application, like we have seen this example, I guess every one of you might have seen this, in case of Instagram, in case of Facebook as well. Sometime when somebody posts a video and which is not good for the community, which have some explicit content, so what exactly Facebook do? Facebook basically take down that video automatically. Facebook is also working a lot on the fake news. Basically, if somebody is spreading fake news and if they identify it, then they are taking that news down basically. And then there is something called as text-based sentimental analysis, that what is the sentiment of that text. If somebody have written a post, so that text, whatever text he has written, maybe he said that Rajesh is a very bad person and so forth. He have written many bad things about that person, and if other persons are getting affected with that, might be Facebook or Twitter put that into a bad, basically bad text, and it will take that down. So that's how text sentimental analysis work. And then prediction of success or failure, maybe that is also possible. And then online recommendation for the big e-commerce site like Amazon, Netflix. So when we go to Amazon or Netflix, we get lots and lots of recommendation. So how is that possible? How sometime you might have noticed this thing, might be you went to a store and you might be thinking of buying something, or maybe you are talking to your friend, maybe you are searching on a web browser for some sort of mobile, some sort of book, or any different sort of thing that we are searching sometime. So when we go to Amazon, we get the same same recommendation, that are you looking for this, are you buying this? And when we buy a mobile, in that case it recommend that if you're buying mobile, you should also be buying a cover for this mobile. That is very obvious. But in clothing as well, if you buy some sort of clothes, so based on the previous clothing that you have bought, it will recommend you that you might like this kind of clothing as well. So that is called as recommendation engine. So how it is recommending in case of news as well, if you are using Android phones, so on, if you swipe on the right side of your phone, so you might get feeds from the Google. Different news are there, maybe some news related. So Google asks you at the first place, what kind of news you want me to serve you? News related to tech, news related to politics, news related to education, and you give Google some sort of option that these are the kind of news that I am looking for. So in future, based on the previous option that you have given, and now maybe the preferences that you have given at the first place, Google, you might have changed your mind, you might want to read some other news as well. So Google also want to give you this opportunity. Google will throw some different news at you which might not have asked for, and still it is serving you to see, to check if you are responding to that particular news. Also in case of movies as well, in case of Netflix, if you watch some sort of series on Netflix, then Netflix recommend me different kind of series that might be related. Maybe I'm watching a Netflix which is related to sci-fi, so Netflix will identify that what are the different sci-fi Netflix movies or the series that are available that should be recommended to me, so I can watch those series. In case of YouTube as well, this is going on a lot. So that is called as recommendation. So these are some of the example of machine learning. Again, there are endless example. If I will start giving the example, this will take 2 or 3 hours to complete the examples. So what exactly is required to create a machine learning system? So first of all, again, to apply any data science machine learning algorithm, first thing that is required, that is data. And then next thing that is required, that how that data need to be fed into the algorithm. From basic, if I build a basic algorithm, and then I will try to add additional advanced functionalities to that. And then comes the part of automation, scalability, how scalable that model is, ensemble modeling is basically for solving a particular problem. I'm using multiple models, so that is called as ensemble techniques. Basically, maybe I'm using linear regression at the same time, or maybe decision tree at the same time for solving a particular problem. So if somebody is from statistic background, they might relate this a lot. So in machine learning, a target is called a label, and in statistic, target is called a dependent variable. A variable in statistics is called a feature in machine learning. Transformation in statistics is called feature creation in machine learning. So yeah, now what are the different type of machine learning methods? What are the different type of machine learning methods that are available to me? So there are basically three types, three broad categories for the machine learning methods. The first one is called supervised learning, unsupervised learning. Then the last one is called as reinforced learning. So I will talk most of the time about these two. This one is a little about, it's about experiences, basically how we learn in a life. Basically, this is something like we make a mistake in a life. We try to do something and we make a mistake, and then we learn from a mistake, and then we go back and try to solve that problem. Maybe if you go back to your childhood, if you could remember how you started learning cycling. So you pick up the cycle the first day and you start going for driving out the cycle, and you fell off and you realize that you were doing something wrong. You come back again after fixing up yourself and then you start the process again, and then in this process you learn basically. So you make a mistake, and as we said before, we learn from a mistake. So that is what this is the idea behind the reinforced learning, that make a mistake and learn from that mistake and do the process again, do the process multiple times, you will learn it eventually. So in case of supervised learning, again, supervised learning, basically some of the examples I would say in case of supervised learning are something like population growth prediction, basically how the population growth is going to happen in next few years. Estimating the life expectancy.
ਮਸ਼ੀਨ ਲਰਨਿੰਗ ਹੁੰਦੀ ਕਿ ਹਾਂ ਵੀ ਮਸ਼ੀਨ ਨੂੰ ਟ੍ਰੇਨ ਕਰਨਾ ਵਾ।
Can you please put yourself on mute?
ਹੈ ਇਹ ਤਾਂ ਚੱਲਦਾ ਪਿਆ ਅੱਜ ਕੱਲ, ਐਟ ਪ੍ਰੈਜ਼ੈਂਟ ਇਹ ਚੱਲਦਾ ਪਿਆ।
Ma'am, can you please put yourself on mute?
ਪਾਇਥਨ ਤਾਂ ਨਹੀਂ ਕਰ ਲਈ, ਮੈਂ ਕਰ ਚੁੱਕੀ। ਇਹ ਅੱਗੇ ਪਾਇਥਨ ਤੋਂ ਅੱਗੇ ਆ, ਹਾਂ ਕਿ ਉਹ ਯੂਜ਼ ਕਰਕੇ ਅਸੀਂ ਕੀ ਕਰ ਸਕਦੇ ਆ ਪਾਇਥਨ, ਉਹਦੇ ਚ ਕਿੰਨੀਆਂ ਬੜੀਆਂ ਲਾਇਬ੍ਰੇਰੀਜ਼ ਆ ਨਾ।
Okay, so yeah, I was talking about supervised learning. So in machine learning, basically there are two types, as I said, that we are going to talk about. One is called unsupervised learning, one is called supervised learning. So in case of supervised learning, there are two types again. One is called classification, one is called regression. So classification is something I am defining my goal into two types. Like the first example that we saw, that was for the cat and Jerry and Tom and Jerry example, when we were creating two classes, that if I see a picture of Jerry, I will put into a class which is called as Jerry. If I see a picture of Tom, I'll put into a class which is called as a class of Tom or Jerry maybe. So then there is something called as, I was explaining you about the example for the house price prediction example. So that is a regression kind of problem. Basically, I need a continuous output. The price of a house could be different looking at a different variable. If I look at more examples, so these are some of the examples like population growth predictions, then estimation of life expectancy, market forecasting, weather forecasting, popularity predictions, basically. So these are some of the regression problems that we try to solve with the help of supervised learning. Then in case of classification, we will have these kind of problem like identifying a transaction. If it is a, so there are going to be two classes. If that transaction and the transaction take place, there could be two possibilities. Either that transaction is going to be fraud, or either that transaction is going to be a legit transaction, not fraud transaction. So I will have now two classes for the fraud and not fraud. So that is a kind of problem which is called as classification. I have two classes that I need to define my transaction. Then image classification, as we have seen before, Tom and Jerry example, I have two classes, Tom and Jerry. Either the image is going to be of a Jerry or either the image is going to be of a Tom. Then there is something called as customer retention. So am I able to retain my customer or not? There is going to be either retention or not retention. Then again, diagnostic, in case of maybe I want to diagnose if that person, what are the possibilities of this person developing a disease, maybe a cancer, breast cancer, different kind of diseases are there. So if I want to, either that person is going to have that disease or either not that disease. So yeah, that is a supervised learning. So in all these classification regression, I am going to give it a features. So how that transaction is going to be fraudulent, there are going to be certain features. Basically, what is the amount of transaction, from where that transaction took place. There are different parameters to that I need to take into account. Then diagnostics as well. What is the size of the tumor, what type of tumor is it, how long that tumor has been into the system, and different sort of features will be there. In case of unsupervised learning, I really don't have any features. Basically, like in case of recommender system, there are no features basically. And again, target marketing, how you are going to target different audiences, they're not going to be fixed features that you will be targeting. Then customer segmentation, and these are, again, in clustering also there were two problems. Clustering is something defining my output into two clusters, or into two, you can say, two groups, three groups, four groups. In case of recommender system, I might have a different recommender system. Like in case of movie recommendation system, I might have movies which are related to sci-fi movies, maybe dramatic movies, maybe romantic movies, adventurous movie, different type of movies. Then there is something called as unsupervised learning, which involves a lot of advanced features. So something called as big data visualization and meaningful compression, then structure discovery and feature excitation. So these are some of the advanced functionalities that can be achieved with the help of unsupervised learning techniques. So now what exactly is supervised learning? Let's go into detail about it. So in case of supervised learning, if I'm giving this raw data to my machine, I am also telling what this data is about. This data has three different figures. I'm telling that this kind of figures are called as hexagon, this type of figures are called as triangular, this kind of figure are called as square. I fed it to the model, and the model will learn from these figures, comparing, and it will make the prediction how well it is doing. Is it making the right prediction? Is it making the wrong prediction? Now, once the evaluation and prediction part is done, then I will feed the test data and I will ask it to predict. I will ask it to define into two classes, and then I will get output as like this. One of them will be defined in this class, which is called a square. One of them will be defined in this class, which is called as a triangular. So the purpose of this method is for this algorithm is able to learn from comparing the actual output to the taught output, and to find the error and modify the model accordingly. So supervised learning therefore uses a patterns to predict the label value on the additional unlabeled data. Because this is an unlabeled data, I am not going to tell my model whether this is a triangle or whether this is a triangle. So I'm asking it to predict. So then getting this unlabeled data, it will make the prediction and it will put it into a labeled data basically. Again, this is one of the examples. I have this sort of data fed into the machine learning model, and it is defining into two categories basically, three different colors. Then there is something called as unsupervised learning. So in case of unsupervised learning, the data is unlabeled for the algorithm to left find the. So what exactly, if the data is unlabeled, what exactly the algorithm is going to do? Obviously, it have to find the commonalities. What are the commonalities in the data basically among the input that it has received? And unlabeled data is more abundant. And I said at the first place, it's like more than 80% of the data is unlabeled data. And machine learning method that facilitate the supervised learning, unsupervised learning are particularly valuable. Like in case of clustering, I'm able to divide the clusters basically. So the goal of unsupervised learning may be as straightforward as to discover the hidden pattern within the data set. So for example, could be for the unsupervised learning, like maybe you're working for a telecom company and they want to set up some towers in a particular region. So what should be the position of those towers, the the telephone towers that they want to install, that all the other customer in that particular region would have the best connectivity, would have the best internet speed, would have the best connectivity, would have the best quality of calling rate, calling basically to each other. There would be no lag in the calls, all sort of things. So you will divide your whole city into different clusters, and then based on the clusters you will put towers in that particular region. So again, this will be the example. Like in this case, I'm feeding this data to my machine learning model, and I am not telling what are the different classes. Is there any class in it, or no class. I'm not telling about the labels basically. So I'm asking my model to learn from it, to look for the similarities. What are the similarities we find? Based on the similarities, just the way we learn. That is how we have learned so far in our life. If I show you some pictures and I show you different pictures when you were a kid, you will learn automatically, and you will learn automatically, okay, this is the same picture that I have seen the last time. And when I show you that picture again, you will be able to relate to that picture. Okay, this is the same picture that I have seen before. So yeah, this is what I'm expecting the unsupervised learning algorithm to do, to define my data or to divide it into two different categories. And if I have two categories or three categories, so as you can see, it has defined it into two categories, or as we say, clusters. Basically, it has divided into two clusters. So yeah, then what exactly it has been used for? So it has been used for a lot transactional data. So if you have a large data set of customer with their purchases, and with this data fed into the so for a person, for human being, it's very tough to find out the patterns in that transactional data, or to read out even the whole data basically. So if I fed this data to my unsupervised learning algorithm, and it might determine that the women of certain age range who are buying unscented soaps are likely to be pregnant. And based on this, basically what I can do, basically make the marketing campaign related to pregnancy and baby product that can be targeted to this set of audience, which is buying unscented soaps basically. So yeah, then what are the advantages basically? So the most important advantage is that without being told a correct answer, unsupervised learning method can look at the complex data that is more expansive and seamlessly unrelated in order to organize it in a potentially meaningful way. And this is the advantage that you have of the unsupervised learning models basically. So this is how the supervised learning is going to be. If I give him two data sets of different categories, what will do, it will divide them into, maybe through a line, or a difference, maybe it could be a straight line, or maybe it could be a parabolic line. This sort of, in this way it will create a boundary. And if the data is on this particular side, then it will be in this category. If this is on this side, it will in this category. In case of unsupervised learning, it will divide the data into clusters, and based on the similarities basically, that what are the similarities for it. For a clustering example could be something like, it's very vague example I'm going to give you if you're not able to find a clustering example. For example, let's say that if I say that if a vegetable seller walks in your street, in front of your house, and he have maybe some sort of tomatoes here. Tomatoes are this location, and potatoes are this location, and maybe what could else, tomatoes, these are tomatoes, these are potatoes, and these are onions, basically some onions. So maybe what happened, there is one object is there. So if it is a potato, and if how the seller is going to put it into this category, why? Because this is similar to this particular group. It has similarities for this particular group. It has the same color, the same texture, and it will automatically put it in this particular group. If the tomato or the onion comes in here, then we will put it in here. But machine learning, what exactly, in case of machine learning, the machine learning will, unsupervised learning, what exactly it is going to do, it is going to check the distance basically of a tomato or a potato, whatever it is, from all the different clusters, and whoever has the least distance, it will put it in that particular category. Maybe it goes here. So this kind of thing are done in case of unsupervised learning, to define cluster. And if I give him any random input and to find out what cluster it should go in, then it will check the distance from all the clusters, and then it will put it in a different cluster. Then comes the part which is very fascinating to everyone, I guess, which is a deep learning concept. So let's see what exactly is deep learning. Give me 1 second. Okay, can we focus on the presentation, please? We will discuss these questions at the end of the session, as I said before. About the certificates, whatever doubts you are having, we'll discuss them at the end of the session. So please pay attention on the session, because this is very valuable for all of you. So if you could focus here, that will be much better. These questions can be addressed at the end of the session. So please pay attention. It is my humble request to everyone. Okay, now looking at deep learning, what exactly is deep learning? So deep learning combines advances in computing powers. And if somebody asked me this maybe 10 years ago, that deep learning concept was still there, but is it possible to apply deep learning? So I would say no, because at that point of time we were not having that much huge amount of computing power. We did not have cloud at that point of time, and we don't have this much computing resources available to us. So I would say that is not possible in today's age. The amount of computing power that we have, if somebody asks me, is deep learning is possible, applying a deep learning to solve a problem, so I would say definitely yes. And how is it possible? It's possible only because of the computing power that we have. Because deep learning, basically they are using neural network. So neural network, taking the inspiration from our brain, because our brain is also made of neurons. And I guess there are 2 billion neurons in your brain. If you could Google it up, you will find it. There are approximately 2 billion, I guess, neurons in our brain. So it has taken the inspiration from our brain, and this was the reason for the deep learning to come into picture. In the first place, it was like to understand our brain, and to see, by developing some neural network which will depict our brain, are we able to understand our brain, how actually our brain works. So we have figured out few things, but not exactly that how actually our brain works. But yeah, we have got this amazing method, or technology, which we are using nowadays every now and then to solve a real world problem, basically the deep learning. So deep learning techniques are currently the state of art, and for identifying the objects and image and words in sounds, basically. And the researchers are now looking to apply these successes in pattern recognition and to more complex tasks, such as automatic language translation, medical diagnostic, and numerous other important social and business problems. So these sort of problems they are trying to solve this sort of problem, basically with the help of deep learning and neural networks. So in case of if somebody asks you what exactly is deep learning, so deep learning is a neural network, basically. It is working on the neural network concept, and doing some sort of analysis on the data, and then giving the prediction as the output. So then comes the concept of data mining. Now, data mining can be considered as a superset of many different methods to extract insight from the data that we have seen before, different methods that were there, like in case of machine learning as well, in case of deep learning as well, data science, data analysis, all sort of things. It is a superset, basically. So it might involve traditional statistical method and machine learning. And data mining, basically what it do, it applies methods from many different areas to identify the previously known patterns from the data. So as I said before, what exactly we were doing in case of machine learning, we are looking at the previous patterns and trying to recognize them, and then making the prediction for the future. So this can include the statistical algorithm, machine learning, text analytics, time series analysis, and other area of analytics, basically. So data mining also include the study and practice of data storage and data manipulation. So how to practice this amount of data, how to store this amount of data, basically how to manipulate this amount of data. So data mining defines all these studies. It has all the studies, and it has all the procedures written down for us, that how exactly we should be dealing with this large amount of data. So how exactly data mining works: understanding the business problem, and then data understanding. But after understanding the business problem, the business might give you some sort of data. So understanding that kind of data, what that data is about, how the data is segregated across different rows, different columns. Are we able to fed this data into the model in this particular way, or do we need to prepare it? to fed it into the machine learning model that the model can understand. So might be I have to do some sort of data cleansing, data preparation, and then there will be modeling part, and then after the modeling part we will do the evaluation, and then the deployment. We'll deploy it in our servers like Amazon or my AWS, different kind of servers that are available to us. So what are the techniques that are there? Again, these are again going to be the classification technique, the clustering technique, the regression technique. Again, association rule is there, prediction rule is there, sequential patterns is there, but I will talk about these two. So what is the basic difference between the classification versus regression? So if I give a student profile based on the classification, in case of classification problem, so it will give me whether the student is going to be pass or whether the student is going to be fail in the test result, or maybe there is a test going on, and it will say in case of classification it will give me pass, it will give me two categories, whether that's going to be pass or whether that's going to be fail. In case of regression problem, it is going to give me some sort of percentage value that based on the student's profile, maybe how that student perform in the different test, how is it doing in the extracurricular activity, how is active in the class or not, it will give me the percentage value, which is going to be a continuous value and which is going to vary for all different students, right? Of course there could be a possibility two students could have the same percentage like 85, but in most of the cases it is going to be different for all of the students. But in case of a classification, either it is going to be pass or either it is going to be fail. Two categories I have. So this classification task is going to put them into one of the categories. Either the student is pass or either the student is fail. Then again, as I said before, it will create this sort of decision boundary. So if the input is on this side, then it will consider in this type of category, and if it's on the other side of the boundary, then it will be considered in this type of category. Of course there are going to be certain outliers, as you can see this has to be in this particular side, but it is on this particular side. So there are techniques as well to solve this sort of problem. And in case of basically regression, we are trying to plot a line, basically a straight line, by using the formula yx is equal to mx plus c, which is the equation of straight line. We are using that particular formula, and then we are getting the different output. Maybe this could be like, if I have this input, what is going to be the output? 30 is the input, then I would say the output going to be maybe somewhere around this point, which might be 30 as well. If I say the input is 40, what is going to be the output? So they are following a linear relation, which is x. If this is x, this is y. So they are following the relation x is equal to y. If the value for x is 1, the value for y is also 1. If the value for x is 2, the value for y is also 2. So this is the basic difference between the classification and regression. Now, what are the applications for data mining? So there are endless applications, again, as I said before, but I will talk about few of them. So in case of communication, data mining techniques are used to communicate sectors, to predict the customer behavior, to offer highly targeted and relevant campaigns, basically. So if you are working for the marketing company, or maybe for a retail company, if you're selling some sort of product, then you would require this. You want to find out the pattern in your customer behavior, how your customer is behaving. Yes, Rashi, you will get the presentation, don't worry. If you could please focus on the presentation, that would be better.
Sir, I have a question to ask. May I?
Please keep that for the last. Please note it down. I will take the question in the last, because that will
Okay,
disturb
sir.
the flow and everybody will not, get distracted with that. So
Sorry,
I will
sir.
take
Okay, sir.
in the last.
Okay, sir. Thank you.
Yes, sure. So insurance, basically how it's been used in the insurance sector. So data mining help the insurance company to price their product profitable and promote new offers to their new and existing customers. So they can also decide the premium that based on the life expectancy of the customer, they might decide the premium. If the life expectancy is very higher, then they will come up with a higher premium, basically the premium that they are going to charge the customer. Then education. In education, basically data mining benefit educator to access the student data and predict the achievement level, and find the student or group the student which need extra attention from the, for example, student who are weak in math subject. Then in case of manufacturing industry, with the help of data mining, manufacturer can predict the wear and tear of the production aspect, and they can anticipate the maintenance, which helps them to reduce the minimizing the downtime basically of a machine. Then in the case of banking sector, data mining helps the finance sector to get a view of the market risk and manage the regularity compliance, basically with the help of RBI. RBI will do that. So it helps bank to identify the probable defaulter to decide whether to issue the credit card, loans, etc. Then in case of retail sector, data mining technique help retail malls and grocery stores identify and arrange most sellable items in most attention possible. So the items which are going to sell more, they are going to put them in the front door, nearby the front door. When a customer enter into the store, they'll be putting them in the front, the shelves, maybe that it takes their customer attention. So it helps the store owner to come up with the offer which encourage the customer to increase their spending, basically. So like this sort of offer we get a lot. Maybe if you spend 10,000, then you might get a coupon of 1,000 rupees, and if you will purchase this product, then you will get one other product free, that sort of thing. So then comes the data scientist salary in India, and so let's take a look at that. So career opportunities in data have exponentially grown in the recent few years, and companies are eager to capture data and drive insight from it because technological advancement we are seeing. So accessibility of the data today can help to reap the multiple benefit of organization from it. And companies are throwing huge salaries at those having the skill to take on the position of data analysts, scientists, engineers, etc. So India is the second highest country to recruit employee in the field of data science or data analytics, second only to the United States. The demand of data expert is equally competitive whether you look at the big companies, the e-commerce industry, or even the startup. Thus, if you have the required skill set and are ready to keep yourself updated, your career as a data scientist is expected to grow and keep growing onwards and upwards. So this is the chart that you can look at and compare the salary, the average base salary for a data scientist in India and the base salary of a data scientist in US. So this is how much they are getting paid. In India, it's approximately close to 10 lakh, and it's in US, it's close to $117,000. This is the lower bracket. In case of India, this is 4.6 lakh is the lower bracket, and the average is almost 10 lakh, and the highest is basically close to 18 lakhs. Then the roles of data scientists, let's see. So what is data scientists, what they do? So data scientists are inherently analytical expert, data expert equipped with the requisites to solve the complex problem, complemented with the unquenching thirst of exploring a wide array of issues that need to be addressed, basically. So they are highly skilled individual combining the best of both worlds, IT and business. So a programmer who is only a programmer, who does not have a business knowledge, he cannot be a data scientist. And if a business person, he have a knowledge about the business, he know very well about the business, but he does not about the programming, it is not about the IT world, how thing works in IT world, so he cannot be a data scientist. So hence data scientists are part computer scientist and part mathematician and part trend analyzers, because they analyze the trend as well, they use mathematics as well, and they are doing different scientific operation on the data, so they are also computer scientists. So what are the requisites for what are the requisite skill for data scientists? So the knowledge of different algorithms, statistic, mathematics, and machine learning is required, and then also the programming language such as SQL, Python, SAS, and Hive, the big data framework, is required if you are working for the big data industry. Otherwise, for a beginner, the Python and SQL is enough. The business understanding and the aptitude to frame the right question, because you will be paid to ask the right question and to find the answer with the available data that is there. Because sometimes when the client comes to us, they want to solve a problem, but they don't really know what exactly the question we should be asking the data. So then we have to put them, you know, that these questions that we might try to answer, you know, we might find the answer from your data basically. So they'll say, yes, go ahead and find the answer and come up with a solution to me, and then we'll take a look at that. So communication skill is in a, you know, it's all the communication result in effect, because you will be communicating with the client, you'll be communicating with different teams which are working in the data domain. Might be some of them working in the data integration domain, some of them will be working in the ML domain. So communication skill is very, very important in this case. And of course, the one thing that I missed on, it's storytelling, because your data will have a certain story and you want to put in a way that everybody can connect with that story. So storytelling skill is also very important. So then these are some of the roles that are there for data science: data scientist, data architect, data engineer, statistician, decision scientist, machine learning engineer, data science manager. So data scientist, data engineer, and data analyst, I will look at 3 of them. So these are the salary ranges in India for the data scientist. If a data scientist has less than 1 year of experience, the salary that he gets close to 5 lakhs. If he has 1 to 4 years of experience, the salary, again, it depends on many other factors as well. This is just the information that I got from the pay scale, and I'm just showing it to you. It depends on person capabilities as well, and the kind of project that you have worked on, and the industry and the location as well. So this sort of salary you can expect if you have close to 1 to 4 years of experience. If you have 5 to 9 years of experience, then you would get a salary close to 1 million. And if you have 10 to 20 years of experience, you can expect a salary of 2 million basically. So data engineer salary in the range. So according to Glassdoor, the average data engineer salary in India is 8.5 lakhs. And the data engineer salary depend on, again, several other factors. Obviously there are other factors on which this depends: the size of the company, the reputation, the location, the geographical location, the educational qualification, and the work experience. The reputed companies and big players in the big data industry like Amazon, Airbnb, Spotify, Netflix, IBM, Accenture, and all these companies are paying very high compensation to the data engineers, because they will be dealing with the data. The job of a data engineer will be to deal with the data, how to take the data from one source and connect it to how to fed that data to the machine learning engineer, and then the machine learning engineer will work on that particular data and then develop a machine learning algorithm on top of it. And this is the pay range for the data engineers. So for 1 year, less than 1 year of experience, or close to 1 year of experience, they are getting 4 lakhs, and 1 to 4 they are getting 7 lakhs, and 5 to 9 1 million, and then 20 million, and so on. And this is the for the data analyst basically, and this is the salary for 1 to 4 years of experience, close to 3.94 lakhs approximately. 5 to 9 years, 6 lakhs, and 10 to 19 years, it's like close to 99 lakhs. Again, it depends on other factors, as I said before. So yeah, now if anybody have any question, please go on. You can unmute yourself one by one and then ask your questions. Nobody have a question?
Hello, sir. I have
Yes.
a question. So my question is about state of art, a basic meaning. Whenever there was a use of term state of art, what do you actually mean by that?
That means complex problem that cannot be solved, you know, with the help of machine learning. Complex problem like I would say image recognition. So the image recognition, if you give me a video recognition or sound recognition, so that cannot be done with the help of machine learning. So that is possible with the help of deep learning.
Okay. And so one more thing, when it is about data collection or extraction or finding patterns from the data using deep learning, and one is using data mining techniques. So what is there's a difference between both the two techniques now when we are extracting the data and
As I
predicting using statistical methods.
As I said, the data mining is a superset of all the techniques. So in data mining itself, you are going to use machine learning, you are going to use deep learning, depending on the complexity of the problem that you're trying to solve. So it's basically the superset.
Oh, okay. So as we already study, in AI we have ML, and ML we have DL, है ना? And so it
Right.
means the data science set is like superset of all these when it comes to
Sorry.
applying finding patterns in them. It means then data mining is a superset to all this when it comes to extracting the patterns from the data.
Yes, yes, yes. Artificial intelligence is basically the superset of AI and all, but data mining is using all these techniques basically.
Okay, sir.
Yes.
Thank you, sir.
Hello.
Yes, yes. Go on.
Hello, yes, sir. Sir, I have a question, sir. How to relate a machine learning project to a web dev?
Sorry. How to create a machine learning project in?
Machine learning project with the help of web dev means how to connect both of these two technologies. So, is there a technology which we need to learn, or we can just learn a framework?
You are saying web development. You are saying how to connect machine learning with web development. That is the question.
Yes, sir.
So basically, yes, of course, you have to learn. First of all, you have to figure out the problem. What exactly is the problem that you are trying to solve? And then you have to think of how to solve that problem basically. So there is a whole procedure that we have to follow. First of all, there has to be the data gathering. If you have certain problem that you want to solve, maybe you can build simple project. Maybe on a website you can build off a chatbot basically with the help of NLP, that when a customer comes in, you are able to understand your customer query with the help of NLP. Whatever he's writing, you are able to understand that and then show him the output based on that. So this sort of thing can be possible.
Okay, sir.
So
Is there so can we include the machine learning in the Django framework?
yes, it's used for the deployment now. At the end, what
Yeah.
exactly we want to do? When I build a machine learning model, obviously I want to expose it to web. So obviously I will be using Django or Flask, any one of them, depending on the the application. Is it a small application? It's a large size application, depending on that. So I will be using that at the end. That will come at the end. The deployment part, the thing that you are asking, that is a part of deployment basically. But before
Okay,
going
thanks,
to
sir.
the deployment, I need to build up the project. So before anybody asks question, what I'll do, I'll show you one of the basically the basic model that I have built, so that you can have the understanding of the linear regression, just to give you the basic understanding. So give me 5 minutes and then you can start your question again. Please wait for 5 minutes. Okay, let me show you an example of the linear regression, how I have solved this business problem basically. So in this business problem, what exactly I'm trying to do is basically, given the production budget, I am trying to predict the worldwide gross basically. So I have collected the data for the movie's budget from different resources, and I have put it in a CSV file. And this is something my CSV file looks like, as you can see. So first of all, in order to work on this file, I need to import the basic libraries like Pandas, and from Pandas I'm importing data frame, and then matplotlib I'm using for the visualization, and from the scikit-learn I'm importing the linear model basically, and from linear model I'm using linear regression, which is one of the regression technique that is available to me. So I'm using this technique to solve this particular business problem. So first of all, I'm trying to read my data. My data is available in this CSV file, and I'm using the read pandas function which is available to me, and then I'm running this describe. So this describe function is giving me the summary of my data. What is the mean value, what is the standard deviation, minimum, 25%, 70%, all this information, and it is giving me in the scientific notation basically. So if I want to convert it, if I want to find out maybe about the what is the mean production budget, so this is in scientific notation, and I can convert it in this way. So this is the mean budget that I am getting basically. So then the next thing that I'm trying to do, I am trying to divide two of these this one column and the other column into two parts, X and Y. So X basically will store my production budget, and Y will store, which is my target variable, which I'm trying to predict. It will store the worldwide gross, that how much money that particular movie had made. Then what I'm trying to do, the next thing that I'm trying to do, I am trying to plot the graph, because just by looking at this data, these numbers, if I show you the head of the data, I will not be able to understand anything until unless I do the visualization. So if I show you the head of this data, this is something it looks like. This is the top 5 rows and top five rows of my data. So I am not able to find anything from it. But if I put it in a chart, maybe this sort of chart, so I can have different inferences. What I can see is there are lots and lots of movies which have a budget close to 0 to 500 million, and that there are lots of movies which are in this particular range, and there are very less movies like Avatar which has a budget of this in this particular range, and then they have a production gross close to 3 billion, not exactly 3 billion, but yeah, close to that. And this movie have budget close to 4.2 or 3, I guess. So this is some sort of outlier that is there in my data. But again, what I can see clearly that they are following a linear relation. If one value is increasing, other value is increasing, but how much linear they are, that's what we want to find. Basically, we want to put a line up here, but how that line has to be found? With the help of linear regression. And then to use the linear regression, I am using linear regression, creating the object, and then I'm fitting my data. Regression.fit, I am fitting these point X and Y point. X basically is nothing but my production budget, and Y is basically the worldwide gross. So if I run this sort of output I get basically. And now if I want to check the coefficient, which is going to be the theta1 value, as I said before, it's going to be like Y is equal to mx. So this is basically going to be the theta1 value, and this is going to be the coefficient. And now if I want to make the predictions basically of my predicted values, so this sort of output I'll do, and then I'm able to fit the line on my data. Now for a movie which has a, what exactly this tells me, let me interpret that for you. For a movie which has a production budget close to 3 billion, I guess this is a value in billions basically, and they will have the revenue, the worldwide gross close to this particular value, and this is my score basically. But how accurate my model is doing, again, it's not doing very well. It's giving me accuracy close to 54%. So it's not doing very well because I haven't done anything in this case basically. Because I have a large data set only at this particular point. So now what we learn from this problem is the data set has to be normally distributed. That means I need to have the data distributed all across when I'm collecting the data. But this was the anomaly in this particular case. The data that was there from the different resources that I've gathered, most of the movies were following in this particular range, and that is why this model is not predicting very well. That is why it's giving me only 50% of accuracy. Now I guess it's making some sense to you that how these models are being applied, and you can see how simple is it. We find it complicated. It's very simple. Simply, I have not written any code for using the linear regression. I have not written any equation for solving this particular problem. Simply, I have imported linear regression from a library in which the scikit-learn people, they have already written the code for me. I have simply imported the linear regression and simply applied it. That's all what I did. Now you can go ahead and ask a question. You can unmute yourself and ask a question.
Hello, sir. So my question is, what are the other standard libraries other than scikit-learn for machine learning?
Now scikit-learn has almost all the all the models, the basic models are there. Of course, there are other libraries for NLP like Spacey, NLTK library for NLP, like natural language processing for understanding English language, that sort of thing. So there are different libraries for that, like NLTK and Spacey.
Okay, sir. My next question is, what is the role of data science manager?
Data science manager, so he will be managing the teams, different teams that are there working on different projects. Maybe you are working for a company as a data science manager, so in your company you might not be working on one project, you might have multiple projects. So the data science manager will be dealing with the client, understanding the client requirement, and then coordinating with all the other people in the team, basically how exactly the project is going on. He's monitoring their performance and all sort of things. The monitoring part will be done by them, and
Okay,
if they are
sir.
stuck
Thank you.
yeah, if they need any assistance, so he will help them out with that.
Hello.
Yes, please go on.
Hi, sir.
Yes, please go on.
Sir, I am audible to you.
Yes, you are. Go on, please.
Okay. So, sir, my name is Bhavesh, and I'm not from that programming background. But means I have lot heard about that data scientist, machine learning, and all about that. So means
Yes,
for a basic for a means a person like me, how can I start to go in a data scientist field in a machine learning? Means what I have to do? Means I have to learn some programming language or something like that. So can you please some guide in this matter?
Yes, as I said before in the presentation itself, first of all we have to learn Python, and these are some of the library. The basic Python we have to learn, that what are the primitive types available in Python. We have to create some sort of programs in Python. The basic understanding of Python needs to be done, and then we learn the different libraries of that are there in the Python, which are used for data science, like Numpy, Matplotlib. And after understanding these library, then we'll move to the model building part. So you can see how difficult or how easy it was, how many lines of code I have written to solve this problem for predicting the movie gross worldwide, the revenue of a movie from a budget.
Yes.
How many lines of code I have written. So that's why we are using Python. So if I'm doing the same task in case of Java, I might be writing maybe 1,000 line of code for solving the same problem. So that is why we are using Python, because it's very easy. It's for a beginner who is not aware of programming, for them to understand, to relate with it.
Okay, so
Yeah,
sir,
that's it.
can you please suggest some means from where I can learn this Python, means basic programming, because I have too much of office work, so means I don't go means too much time to that learning part. So right now it is a good thing we are working from home. So means is there any certification course, YouTube
So
channel
you can
is
enroll
where we can learn from?
you can enroll into our
Yes,
program,
sir.
into Python programming program that we have, the course that we offer. You can enroll into that.
Okay, sir. So can you please share that link?
That what?
Sir, that link.
Yes, sure. I will.
Okay.
Hi, Nandesh. I would like to add one point here in this question. I also not from the CS or IT background, and so I want to ask that is it required to have any knowledge of C or C plus or any Java before starting Python learning?
Not required. Not at all.
It is not related to any other language right now?
No, not related.
Okay, so we can easily start the Python without any other knowledge of the programming.
Yes.
Okay.
Absolutely.
Okay, thank
So
you.
somebody was asking for the link. I have shared the website link with you.
Hello, sir. Hello.
Yes, go on.
Yes, sir. What's the difference between SVM and the knife-based use cases? Like, where can we use the
Sorry?
both of those things, the knife basis and the SVM?
So
So supervised
basically,
learning.
yes. So they are basically SVM using something else. SVM is using take your data into different basically plot different dimension. Basically, it takes your data, it creates a different dimension out of your data. If maybe I have my data in 2D, it will take my data into 3D and then differentiate them. So in this case, as you can see, so let me show you that. The example that I was showing, some of the we have created a boundary, still some values were on the other boundary of one class. Let me show. So that problems get reduced a little bit. So as you can see, this boundary I have created, this decision boundary. So I have created the decision boundary in a way that this is from the logistic regression. I've used logistic regression up here. So what I want the green points to be on this particular side, and I want the red points on this particular side. But as you can see, some of the green points are moving to this side basically. So that problem can be solved with the help of SVM basically. So again, SVM is a different technique, and knife based is different technique basically. One of them is used for clustering and one of them is used for classification.
Okay. And sir, one question is also, sir, there are some startups which can predict that your song is going hit or not. So sir, what are the data they can use for predicting that this song is going for like hit and not?
Sorry, what did you said?
Sir, there are some startups in the US based that can predict that your song is going for hit or not. Like your song is like in trend or not. So sir, what's the data they are using for predicting this information?
I did not get your question. Your song is going hit. You are asking for a song,
Like
or there is some company.
yes, sir.
Can you give me an
Yes,
example
sir.
of the company?
So just,
The name of the company?
actually, sir, give me 1 minute.
Because I'm not really sure of, and they will not really share the algorithm with anyone. What exactly they are doing and what source of data they have gathered. That is obviously their patent. They are not going to share with you. But if you want to solve this problem, then you have to get your own data and prepare your own data for that, for solving the same problem, if whatever
Yes,
problem they
sir.
are solving.
Okay. So there is a startup from the Spain base. So its name is Polyphonic HMI.
Okay, can you
So
share the
they are
link
predicting.
with them? They
Sir,
are
you can type
predicting.
in
Yeah,
Google.
go on.
Sir, you can
Yeah,
type
go
in
on.
Google polyphonic HMI. So they can predict your song is going for hit or not. So sir, how they
Okay,
can do it?
okay.
Data they are using.
I'm not really I'm not really sure what kind of algorithm they are using. So what is the name of the company anyway? I'll take a look. Maybe if I can find some. Telephone.
Polyphonic HMI. Polyphonic HMI.
Can you spell it
Okay,
out?
I'm type Polyphonic HMI. Okay, I'm type it.
Yeah.
Sir, I have another question. May I ask?
Yeah. Go on, please.
So given a problem, we are given a problem that you have to identify somewhat kind of problem. Let it be XY. Let it be X. So how we could identify which of the algorithms would be used for solving this problem? How would we identify? Is it a classification problem? It's a regression problem, or what is it?
So
Means how from problem how we could identify what algorithm will be applied on it.
So basically, you are saying that you want to divide your prop into two classes, right? What is the output you want? You want the output in two classes? That's what you want?
So
So
I'm asking, given a problem, we are just given this is a problem. This is what output we need. This is the input we have. What ML
right.
algorithm will you apply? This is a question to me. Then how would I
Yes.
identify? What would I use to identify the algorithm?
So basically, it depends on many factors basically. So first of all, it depends on the factor. What is the kind of output that I'm expecting? Is it a continuous value? Is it a numerical value that I'm expecting? Is it going to change every time, or am I trying to define some classes? Like I have shown you in this particular case? I am defining two classes of different colors. So if this is the case, I will be going for some classification problem. So to be very honest, I don't really know what is going to be the best algorithm. I have to try a different algorithm and then come up with this answer. For solving particular problem, what is the best algorithm work? Maybe what I'll do, I basically pick up the basic algorithm. If it is a classification problem, I'll pick the basic one, which is a linear regression, and try to solve this problem. And then if I'm not getting better accuracy, then I might go and try a different algorithm. So there is no generic approach that I can tell you that there is a way. Of course, there is in scikit-learn library that it tells you about how to pick up the best algorithm. If you go to the scikit-learn library, they tells you that if you have this amount of data, then you should be collecting more data. If you have more than this amount of data, then what exactly you want? You want a regression output, you want a classification output, you want to define it into a classes, or you want a continuous value. Then you can check from different algorithm. But again, nobody really know what is going to be the best until unless they apply that. So we have to apply, and then we'll come to know if it's giving me the best accuracy,
Okay, sir.
or if the other algorithm giving me the best accuracy.
Okay, sir. So, for
Yeah, go
example,
on.
I have a problem to recognize the handwrite expressions in maths. For example, I'm having a problem recognizing mathematical expressions, handwritten mathematical expressions.
Hello.
So this is a problem of recognition, that I have to recognize an handwriting that is of mathematical expressions or equations or something like that. So in that case, what would I start up with? Should I directly go up with the CNN algorithm, means applying CNN on that, and or what should I do? Or start it with the beginning, like supervised algorithms like SVM or something like that?
Supervised will not work in this case. We have to go with the neural networks only, and we have to check which neural network works. Is it RNN? Is it only CNN? Is it ANN? We have to check for different one. And first of all, we have to prepare the data. The first challenge that you will get, preparing the data. Choosing the algorithm is the last thing that you'll be thinking about. The first challenge that is there, first of all, preparing your data. Not preparing your data, even collecting the data. Once I have collected the data, then preparing the data.
Online corpus is already available on the same, then it is easy. Online corpus is already available on the same by some journal has already given in data for the same, so we can use that
Then
data and then start up with that same thing.
yes, sure. If the corpus is there, then you can start working on it using deep learning, different neural networks that are there, and you have to check, are you looking for localization in that, and then based on that you can check the network that you want to use. Again, I said that there is no basic or generic approach that is there. So in this problem, of course, looking at this problem, I can clearly say that linear regression will not work. Obviously I have to go for deep learning because this is a critical problem, and that is what somebody was asking, state of the art. So solving this kind of problem it's a state of the art technique that I require, right? So that will be deep
So I was
learning
asking to see.
in this case. Yes.
Okay, so thank you.
No problem.
Sir, hello. Sir, suppose there is a problem like I have to solve a problem like I have to predict weather, like in a particular country or a particular place, and in a particular date, what will be the temperature, humidity, and weather condition, like sunny or cloudy or normal. So here we have multiple targets like temperature, humidity, and weather condition. So is that possible to solve this problem using linear regression?
Yes. Linear regression, you can solve it linear regression, but I will use logistic regression in this case. This can be solved with the help of linear regression as well. Again, I'll try with the first of all linear regression and checking if it's giving me better accuracy, because I have defined features up here. As you are saying, I have humidity, I have temperature, or I have the wind. So I will be able to define them into categories, but I'll check if the linear regression is working well with, and then I'll check for the logistic regression. If the
Okay, sir.
logistic regression is giving best
So
result.
in case of regression, suppose we have split the whole data in X and Y. X for training and Y for testing. So
you don't really have to do that. I mean, there is a technique that is available in case of scikit-learn. Scikit-learn will do it for you.
Okay.
Okay. Next, go on. What do you want to do then? If you have split it, then after that.
Okay. So in Y database, I can insert multiple columns as my target. Is this possible?
No. Why do you want to do that? You already have a target now. When you have gathered the data, then you already have a multiple target. What is the problem, first of all, you're trying to solve? Tell me with this use case.
There is a data set that contains 5 columns like country name, date, temperature, humidity, and wind.
Okay.
And after that, I have to predict in a particular country and in a particular date what will be the temperature, humidity, and wind condition.
Right. So yes, that is possible, as I said before, with the help of linear regression. I will try first of all linear regression, and I think it
Okay.
can be solved. So in the target already, you would have already a target variable there. When you have gathered the data, then you would have a target variable. How the machine learning is going to learn that? You will give it the historical data, how the weather performed in the previous year. The machine
Yeah.
learning is not a magician. You have to tell it how it has performed in the previous years, right? So then
Mm.
looking at the previous year data, it will be able to predict the future, forecast the future.
Okay.
Yes.
Okay, sir. Thank you.
Okay, next please. Next, any other question, please go on.
So the polyphonic HMI.
Sorry.
Yes, sir, I
As a
asked the question before.
Okay, so as I said before, they are not going to share the algorithm with me, what exactly algorithm they are using. You can look into this case
No,
study.
actually, sir, my question is just you saying that you predict the cost of the movie by saying it's that what how much amount they are using. So my question is, what's the data we are using for predicting the song is going for it? So I'm asking about the data, that what
Huh.
things they are need.
So as I said before, you have to you have to collect the data. First of all, you have to look for different resources. If you ask me this problem randomly, so I cannot answer this. I need to look into the use case first of all, that how exactly this problem can be solved. I have to think. It cannot be answered in 1 second. I have to think first of all that what are the different data sources that are available for music, so maybe what I can figure out is, okay, there is Spotify. Maybe if I'm able to grab the data from Spotify website, and if I'm able to find some sort of rating chart, then I might find some relation that the how the music is going to, how the music level is going to perform. I might find different variable, maybe the singer who is that in that artist who is in that song, or maybe I find different relation I find. Then I will try different techniques first of all. So it's going to be hit and trial method. So I have come up with this only hit and trial only. Again, I'm not getting very good accuracy in this case, as I said before. So now to solve this problem in a better way, I need to consider different variables. Again, maybe if that movie is a sequel, if that movie is a prequel, all sort of things, how other platform have, like Rotten Tomato have written rated this particular movie, all sort of things. I might have to consider different parameters. So you have to do the same thing. First of all, you have to collect the data and then try to see, is it forming any linear relationship? Because what I saw, there was a linear relationship. I found two variables, I found a linear relationship, and then I thought, if there is a linear relationship, that means I can apply the linear model on it. The same thing I have to do with the movie, the revenue, the question that you are asking, that can I find this linear relationship between any variable? I have to check for different visualization, and then I will find this.
Okay, thanks, sir.
No problem. Okay, any other question?
Sir, I have a question.
Mm-hmm.
Sir, for like in this movie example,
Mm-hmm.
if we increase the number of variables, the accuracy will increase or not?
Yes, yes, I have to check. I have to check for that. Maybe it will increase, maybe not. It has to. That is what I'm thinking, that it should increase. And for the variable, what are the variable? Are they affecting my movie, revenue? First of all, I have to check if I'm including a, maybe a variable which is a prequel or sequel. If that movie is a prequel, sequel, if that is affecting my, revenue, then I will include it. If that is not affecting, I mean, if I don't see the linear relationship, I will not include it. Or maybe there are hit and trial methods. Maybe I can get lots of variable, maybe 5-6 variable, and I can try building a model and see if it is giving me accuracy, and then one by one I can drop one of them and then check. It's going to be hit and trial basically. There is no specific generic technique that is available to me. I have to try with different techniques and then come up with the best answer, that which one works, which one not works.
Sir, for example, if we check the database of the actor performing in previous movies
Yes.
and how they performed, how the movies performed,
Right.
and if we include that in this model, will the
So
accuracy
again,
increase? Like,
I'm
yes,
not
sir.
really sure. I have to check if that is if that is affecting my movie revenue, then obviously I will include it, and I will check if it's increasing my accuracy.
Sir, I guess I can add something over here.
Yeah, go
As
on.
there can be so many attributes that could be included or excluded. It is, as you said, it's totally trial based. We can experiment over it. For example, as you said, the actor has performed well in the previous movies, or how his movies has gone on the box office. That could be factor. There could be several different factors, and it totally depends upon will that factor impact or not, that we couldn't predict just by seeing it like lame as a dekhkar nahi we can't conclude. We have just to try. We have to take few factors or attributes, and then we have to see the accuracy and compare. Like for the meanwhile, we can take 5 attributes, then we can get some accuracy result, or 6 attributes, and then we could see if our accuracy is getting affected by including or excluding that factor. So we can't conclude as it is. We have to try, and then we can reach to some conclusion.
Right. Well, very well said. Very well said. Absolutely. So as I said before, you cannot be really sure of. You have to experiment. You have to try out, and then you can come up with the answer. So that's how it works basically. So it's all about experimenting, playing with different variables, and then trying to check how well accurate it is, how how bad it is performing, and all of that.
Thank you, sir.
Great. So yeah, feature scaling again, that can be also done. Again, there could be many things that could be done to this. I mean, many things, as I said, but I just kept it simple so that everybody can relate, because for not everybody is familiar with feature scaling, standardization, normalization. I haven't done that, so not everybody is aware with that, Rohit, as you are pointing it out. So yeah, that can be done, and that we can check if the accuracy is affecting or not. Okay, next question please. So talking about the certificate, somebody was asking me about the certificate Venusi. So you will get an email from the management team about the e-certificate. So you can look into your email and then see what they're saying. Okay, any other question for me? Please go on if you have any other question for me.
Hello.
Yes, sir.
Sir, my question is not too much technical, but this is my basic query की means जैसे हम बोलते हैं कि Facebook ने डाटा चोरी किया, so this is so ये कैसे हो रहा है? ये डाटा साइंस की वजह से हो रहा है? सॉरी, ये कैसे हो रहा है? मींस मेरे को मींस आई वांट टू नो कि ये सब कैसे हो रहा है, क्योंकि जैसे अभी आपने जितने भी एग्जांपल्स दिए, सो आई थिंक कि मेरे को ऐसा लगता है कि जो डाटा स्टोलन वगैरह हम सुनते हैं वो इसी की वजह से हो रहा है. सो मेरे ख्याल से दिस इज द डिसएडवांटेजेस ऑफ डाटा साइंस. आर यू एग्री विद दिस?
Again, it's very subjective question that you are asking. It's very subjective. Again,
Yes, sir.
everything which comes with advantages, it also have some disadvantages. So before, like we used to have, we used to call like black, जो oil है हमारा, जो तेल है, वो सबसे बड़ी currency है. उससे पहले सोना जो सबसे बड़ी currency है. But now we are seeing that data is the new gold basically. Data is the new currency.
Right. Hello. So you are not audible. We can't hear you, sir.
So you're not audible.
Hello, session is on. This session is on.
The
Yes,
session is on, ma'am.
yes.
There is some network issue at the trainer's end. I think they have already mentioned this in the message. I think we
Thank you,
must
ma'am.
wait here.
Thank you, ma'am. Thank you.
Ma'am, could you let us know how long will this session last?
Even I'm uncertain about the same, but I guess we should wait. I think there is just a bit of network connectivity issue. It would be just resolved in minutes as said by the services. So I think we must patiently wait for the same. I think in 5-10 minutes we could wait here. No? That is our patience level, I guess. So we must be here.
Yes, ma'am, it's okay for me. Thank you.
Okay.
You guys, can you hear me now?
Yes, sir.
Hello.
Yes, sir.
Sorry, the
Yes, sir.
electricity, internet went off.
Yes, sir.
Sorry.
Yes. Yes, sir. Yes.
Can't really help that. Okay. So yeah, anybody have any other question? Please go on.
Sir, we are on that Facebook and that data stolen.
So as I was saying, it's very, very subjective. So
Sir,
as
I
I said
don't have
before,
knowledge about that. Na? That's why I'm asking that some subjective questions. I
yes,
don't
yes,
have
yes.
any.
Yeah, I get it. I get it. I mean, it's about people, so it's about people and people psychology. So if they see value, in only making money, so they don't care about any other thing, they don't care about ethics and all. But there are also some ethics into data science as well, which we believe that they should be practiced. And if this thing is going on, then that's very bad. That's always not good for the community. So yeah, if Facebook have done it, so that's not ethical, that's not good. But if you say that data science is only the reason, so I would say no, that's not. It's the human psychology, it's the human who are the reason for it. I mean, so if their data science would not be there, there might be some other reason that they would be doing this. So we cannot say that data science is the only reason. It's human, and human behave in different. So it's very subjective, as I said.
Yes, sir.
So that's it from my side, I guess. If you have any other question, please reach out to us on an email, and I will share site that you can reach out
So
to us.
can you tell about Turtle Library?
Turtle library, I'm not really sure of what exactly it does. I haven't really used it, to be very honest.
Sir, I have made the game by using it.
Okay, so it's not related to data science, so that's why I'm not aware. So might be game building. There are different pie games is also there for game building. If you are into game building.
Yes, sir.
Yeah. Okay, guys, then that's it from my side, I guess. Let me share the link to the website, and if you need any information, then you can reach out to us.
Sure, sir.
So can you tell about error prediction?
Sorry?
How to check that our model is fully trained? Is there any error or not?
So we use different techniques for that, like confusion metrics. We use R square for that. We check the accuracy, how well my model is doing by giving, because when I'm testing my model, I divide my data into two parts, testing and training. So from the
Yes, sir.
testing part, I get to know how well it's performing, but there is something called as validation part as well, that I divide my model into three parts, and then I check the validation accuracy, and if the validation accuracy is good, that means my model is performing much better.
Okay, sir. Thank you.
Okay, no problem. Okay, guys, then thank you so much for your time, and have a great weekend. Please reach out